All right, guys, so next thing we're going to take a look at is 6.3 logarithmic functions. All right, this is going to be to an extent, a review of what you guys have already had in Algebra 2, but we're going to expand upon a couple of things as we go forward in this unit. So start with our definition of a log. Logarithm of a given base b of a positive, strictly positive number is the log base b of x written down here, which is equivalent to its inverse form b to the y power equals x. So when I have the log base b of x equals some quantity, what I'm really asking in log base b of x is if I have an exponential base of b and a result of x, find the exponent. I'm asking for the exponent in return. That's my y. Okay. Again, a couple conditions with the log. The quantity that I am taking the log of must strictly be positive. Because the exponential base had to be positive, the logarithmic base must also be positive, and from exponentials, the logarithmic base cannot equal 1. You guys can read the rest of that in here. The only other things I'll mention, then because of the restriction of the quantity having to be greater than 0, our domain is going to be 0 through infinity, non-inclusive, and our range will be all reals. Okay. Similarly to exponential functions, our graph of log base b of x when b is greater than 1 is increasing from left to right. That is going to be a function that will look something like this. And our log base b of x when the base is between 0 and 1 is going to look something like this, depending on obviously what that base is. Will determine how steep that is, so on and so forth, and we can go from there. All right, so converting things to and from logs and exponentials. I said in the definition above that the log base b of x equals y is the same thing as excuse me, b to the y power equals x. You can straight up memorize this, but I've also seen rolling the log, right? So here, think in the order that we went, b to the y power equals x. And the same thing works if I want to go from the exponential to the log, assuming exponential is written here on the left. So if I roll the exponential to a log, I have the log base b of quantity x equals y. Okay, so you can roll it, or you can just memorize the conversion here. So typically I would go through and we would do a bunch of these together. So example number 1 would be something like log base 3 of 9 equals 2. Example number 2 here, we would have the log base x of 9 equals a plus b. In number 3, we would end up with 4 to the third power equals 64. And because at some point way back, probably when I was early teaching, I would make some of the slides in my prep my materials late at night. Example number 4, when we roll this log, we get m to the r power equals g, or my silly math teacher humor, Mr. G. Okay, so we can all get that little chuckle out, right? Yes, I am that corny. All right. Definition of a common log. So the common log is the log that we see on our graphing calculator. Okay, it's over here on the left. It is the log or log base 10. Just like when we have square roots, right? Square root of x is really the square root of x, but I never actually write the index because when I don't write one, it's assumed to be in this case 2. When we're dealing with logs, if I simply have the log of x, this is the log base 10 of x. This is our common log, and with the common log, I do not need to specify that base. If there is not a base specified, it is base 10. Okay. Let me continue on. So our other common log, right? We have the log base 10, and we also have the log base e. So when you see the natural log of x, right, or as some of you would usually say is the ln key on the calculator to the left of the 4, this is the log base e of x, right? This comes from a natural function e to the x. This is the log version of it. Again, we don't have to specify a base because this is a natural log, thus it's implying the natural function e, okay? Its inverse then would be e to the x, right? And I have both of those inverses, I think, written in here. I know it is down at the bottom here, the natural log of e to the x equals x, because the natural log and e to the x are inverses of one another. Furthermore, e to the natural log of x also equals x. Same thing up top, 10 to the log of x would equal x, because these are inverses, and the log of 10 to the x will equal x. Similar to how the natural log of e to the x equaled x. Okay, so some of our equality properties, they work for really any of our logs as long as the bases match, but they also work for our two common logs, the log base 10 and natural log. Okay, so here are my rules, again, written for any base, log base any b of an exponential base b to the n. These will cancel one another out, leaving me with simply n. If I have b to the log base b of n power, those cancel, leaving me with just the n. Okay, so here if I have log base 2 of 2 cubed, this equals 3. Right? I could simplify it and do it the long way and say, well, this is log base 2 of 2 cubed is 8, and then say, well, 2 to the what power equals 8? Well, it's going to be 3. Okay, so we can skip the process here, and based on that definition of what we're really doing, right? Think about this from this perspective. The log base 2 of 2 to the third, I'm saying if I have an exponential base of 2 and a result of 2 to the third, what's the exponent? Well, hopefully that's kind of obvious. It's 3. Okay. The next one here, I have e to the natural log of 7. This simply equals 7, right? The last one, we have a little simplification here. I need to do some like bases. So here I have log base 3 of 3 to the negative third would give me that 1/27th. And here my result is negative 3. All right, one thing I'll mention at this point, we can get results with logs that are negative, but I cannot take the log of a negative quantity. Okay, so there are two different things. I can get a result that's negative with a logarithm, but I cannot evaluate the log of a negative quantity. All right. A couple evaluating functions that we would typically go through. You guys would do these. Take a look, try them, see what you get. If you don't understand what, you are doing here, or if you have questions, see me and we can work through it tomorrow. Okay, again, a couple more here, evaluating logs with like bases. And again, here, okay? Let's do these on this page. So here I have log base 9 of 27, right? Think about this, if I can rewrite with like bases, awesome, right? If not, I can always set it equal to x. Okay, I want to know what this equals. If we roll the log, we're going to have 9 to the x equals 27. And if I rewrite with base 3s, I'm going to have 3 to the 2x equals 3 to the third. Or when I set my exponents equal to one another, we're going to have 2x equals 3 or x equals 3/2. With log base 16 of 1/8, I can do the same thing. We're going to set it equal to a quantity x. Here we're going to have 16 to the x equals 1/8. Or we're going to have 2 to the 4x equals 2 to the negative third. Again, I have like bases. Now I can set those bases equal. We're going to have 4x equals negative 3 or x equals negative 3/4. Okay, so this is all I've got here for evaluating logs. It should be hopefully pretty straightforward, pretty much review of topics you already knew. Again, our use of logs as we go farther in the unit here is going to become more complex. So I want to make sure before we get to that we have a strong foundation and that we're all working from a solid foundation in terms of exponentials and logarithms moving forward. All right, let me know if you guys have questions, and we will see you guys tomorrow.